Welcome to Ecu Flash Training Part 16. In this video, we're going to take a look at working with our lean spool, our periphery bits table, and our MUT table. Now the lean spool is going to be used as a momentary difference in target air fuel as the engine's running from vacuum into boost conditions. It's going to allow the turbocharger to spool a bit quicker. We're also going to find that the periphery bits tables are going to be turning things on or off if we're looking at certain codes, or if we're going to be trying to turn lean spool on or off, or if we're trying to disable or enable our immobilizer. We're able to accomplish that. And our MUT table is going to be defining where we're going to be expecting to log things from when we're working in our Evo scan. So it's going to be important that we understand what to modify in our MUT table so we can log our airflow 2 byte, our load 2 byte, and our RPM 2 byte. That's going to give us increased resolution when we're looking at our logging parameters doing our tuning process. So there's going to be a bunch of things to cover in this video. So let's jump in so we can check this out.
Okay, so let's get started. We're going to be taking a look at our lean spool and some miscellaneous tables and features that we have to work with in our Tephra V7 ROMs. So whether we're going to be on a mass airflow based style calibration or a speed density based calibration in our Tephra V7 ROM, or Evo 8 or Evo 9, these tables are essentially going to be the same, and editing them and working with them is going to be essentially the same. So we're going to be taking a look at our Evo 8 example here, so the 9417 file, and reviewing again our lean spool and some other tables like our periphery bits and our MUT tables so we understand what they mean and how to work with them. So let's jump in here to our current ROM metadata. We're going to go just down our list here, and throughout all the tables and features that we've already worked with, we're going to find the ones that we have not. So we've covered all of our injector data, cranking fuel, post-start fuel, and warm-up fuel. We've covered all of our closed loop information here, going from our closed to open loop. This is going to be essentially our thresholds where it switches, going in and out of closed to open. We've covered all of our idle control here, as well as our startup idle. Moving down here, we've covered our open loop target air fuel table, everything related to our mass airflow style compensations and scaling and calibration here we've covered. We've covered our Excel and decel fuel related items, spark tuning and all the miscellaneous tables, the knock control. We've covered our boost cuts and the boost control settings and the boost type, load or PSI based. And finally, we're going to be settling down here into our lean spool. Now, the lean spool is used by Mitsubishi so that when we're actually getting into boost, so we're trying to get the turbocharger to spool up as fast as possible, we're going to find that a leaner fuel mixture actually makes it have better transient response, or getting the turbine to build enough heat so that it spins a bit quicker. And you actually find that you'll get into boost a little bit faster, and again, you'll have a little bit more transient as you're coming in and out of boost. It'll react a little bit quicker. So what we'll find here, and this is going to be a stock equivalent file, so let's just go up quick into our open loop target air fuel tables. What we're going to notice here, if we jump up into, let's say, our high octane target air fuel, let's jump down here into our lean spool. So what we're going to find is, as we get into boost here, the engine load, we can see 200 kPa and the engine load here, that's approximately 15 psi. Notice the air fuel here in our open loop target air fuel table is going to be pretty rich. It's 10, 9 to 1 air fuel. So Mitsubishi runs the target air fuel tables at a very, very rich air fuel for thermal management, meaning if we are on the accelerator for 10, 20 seconds, it has to run that rich, or the way Mitsubishi has calibrated this table and calibrated the engine, it could potentially have knock. Now, from an OEM standpoint, where we're putting a warranty on a car, you definitely don't want to have knocking conditions or have to worry about having any kind of long-term effect of having either poor octane or just bad driving habits from the general public as they're driving a performance car like this. So they definitely are a bit conservative, and most OEMs are, so that no engine damage is going to occur. So we find that they do target a very, very rich air fuel, and we generally go in and work with a linear air fuel. Now, if you wanted to run a richer air fuel here, let's just say you put your target air fuel here at something like 10.5 to 1 air fuel. What's going to happen is, as you transition into boost, you'll find that the turbocharger isn't going to be as responsive.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.